Hello, my dear student. Very good day to all of you. And today we are going to discuss about the aromatic hydrocarbon. So before going to the deep, we will just start our class. So with the topic, so criteria to be aromatic. Criteria to be aromatic. So what are the basic criteria for a molecule, for an organic molecule? What are the basic criteria for an organic molecule to be aromatic? So basically, one thing we have to remember, that is Huckels rule. Okay, so this is the Huckels rule. We have to remember the Huckels rule. Huckels rule only tells us the exact criteria for an organic molecule to be aromatic. So what are the rule says that the molecule must be planar. This is the main criteria. The molecule must be planar. The molecule must be planar. Okay. Next, the molecule must be of cyclic conjugate type. Cyclic conjugate type with 4n plus 2 pi electrons, and where n is any number ranging from 0, 1, 2, 3, etc., the whole number. Okay, so for a molecule to be organic, for an organic molecule to be aromatic, both these two rules should be followed. Both the two rules should be followed. If any one of the rule, any of these rule is divided off, then the molecule must not be an aromatic. So to be an organic molecule, to be an organic molecule aromatic, the molecule must possess the two criteria. First, the molecule must be planar. Next, the molecule must be of cyclic nature, cyclic conjugate type, must be of cyclic conjugate type with 4n plus 2 pi electrons. Okay, my dear student. So you can write these two norms. You can write these two norms on your copies. Okay, this is the Huckels rule. So to check a molecule in your exam, basically you will be asked some structures, where you will be given some structures, and you are to identify these structures are whether these structures are aromatic or not. Okay, so sometimes these structures are a little bit of critical in nature. So what the tricks? So what are the tricks? What are the tricks to find out whether a molecule is aromatic or not? What are the tricks? Okay, so let's take an example. Suppose you have been given this. So whether the molecule, whether the structure is aromatic or not, this is an ion. What is the name of the ion? First of all, this is the cyclopropynyl cation. This is cyclopropynyl The structure is cyclic. This is cyclopropynyl cation. This is the cyclopropynyl cation. How this cyclopropynyl cation forms? All of we know that this is the cyclopropane. This is cyclopropane. This is cyclopropane. Okay. So, and here the hydrogen atoms are there. In every corner there are two hydrogen atoms. In every corner there are two hydrogen atoms. If you give any base, then the one of the hydrogen atom is being attracted, and it so this is the cyclopropynyl cation. So how this cyclopropynyl cation forms? This is the cyclopropane. This is cyclopropane. So we need to derive the structure of cyclopropynyl cation. So how this cation forms? So this is the cyclopropane, and if you get this, this is cyclopropene. This is cyclopropene in. So basically, cyclopropynyl cation derives from cyclopropene. So it here is the positive charge. Then in this is the cyclopropynyl cation. So this negative charge will be delocalized like this. Sometime okay. So this and this structure is planar, and here the number of pi electrons is 2, because the number of these are the pi electrons. So number of pi electrons, the one pi bond means 2 electrons. So pi number of pi electrons are 2. Therefore it fits with the formula 4n plus 2 pi electron. It will satisfy 4n plus 2 pi electrons formula where n equals to 0. So it will satisfy this. Therefore we can say cyclopropynyl cation is aromatic. This is the aromatic cation, cyclopropynyl cation, derived from cyclopropene. Okay. So we'll see some more example like this. So our second example is like this. whether this type of structures are aromatic or not. If we will given these type of structures are aromatic or not, and this is called cyclopentadienyl anion. Cyclopentadienyl cyclopentadienyl anion. So the cyclopentadienyl anion derives from cyclopentadiene. This is the cyclopentadiene. Cyclopentadiene, and if there will be a negative charge here, one negative charge means 2 electrons, one negative charge means 2 electrons. So this is cyclopentadienyl anion. This is cyclopentadienyl anion. This is cyclopentadienyl anion. This is cyclopentadienyl anion. Look, this. So there are 4n plus 2 pi electrons. There are 4n plus 2 pi electrons. So why there are 4n plus 2 pi electrons? Because in this structure there are total 6 number of electrons. So 1, 2, 3, 4, 5, 6. That means one pi bond means 2 electrons. So there are 2 pi bonds and one negative charge. That means 2 electrons. So there are 6 pi electrons. So it fits with the formula 4n plus 2. So n equals to 1, and this will be conjugated like this, and all the 6 pi electrons will be delocalized like this. So that means the cyclopentadienyl anion is aromatic. So this is aromatic because it fits with the Huckels rule, 4n plus 2 pi electrons, where n equals to 2, n equals to 1, sorry. So total 6 pi electrons. So we'll see some more examples like this. This is nothing but cyclobutadiene. This is cyclobutadiene. So this is cyclobutadiene. This is, so here the pi electrons 4, 2 pi bonds means 4 pi electrons. So 4n plus 2 formula does not fit here. 4n plus 2 formula does not fit here. Here the 4n pi electrons. This is 4n pi electron system. So this is non-aromatic. So this is non-aromatic. So as it fits with the formula 4n pi electron system, this is called anti-aromatic. This is called anti-aromatic. This is called this do not called not aromatic. It is rather called anti-aromatic because it fits with the formula 4n plus pi system, where n equals to 1, 2, 3, etc. So here n equals to 1. That means 4 into 1, that is 4 pi electrons. So in this structure we get 4 pi electron system. So it satisfies the formula 4n pi electron system, and it is cyclic, it is planar, okay, and it is conjugated, of course. So cyclobutadiene is anti-aromatic. Remember, cyclobutadiene is an anti-aromatic. Okay, anti-aromatic is not very stable. than aromatic. So aromatic compounds are very stable rather than anti-aromatic compound. So we write here aromatic compounds are more stable than anti-aromatic compounds. Aromatic compounds are more stable than anti-aromatic compounds. Okay, my dear students. So today we will stop here. In our next class, we will see some more critical uh, examples on this topic, that is aromatic hydrocarbon. So please subscribe our channel. If you do have any queries, you can write down in the comment section. Till then, goodbye.